Welcome back, noobs and pros. You are listening to Kubernetes Notes, and I am Fani Chidala. In this episode, we are going to talk about stateful sets. Before starting, yes, my voice is a little different. I just have cold. Anyway, let's get started. The episode continues after this short message. If you like our work, please consider following us wherever you get your podcasts. Now, back to the episode. Kubernetes has revolutionized how we deploy, manage, and scale applications in the cloud. It abstracts the underlying infrastructure, allowing containerized applications to be deployed across a cluster of machines. While Kubernetes is often associated with stateless applications that don't require persistent storage or unique identities, many real-world applications are stateful. For example, databases and key value stores. The documentation states, like a deployment, StatefulSet manages pods that are based on an identical container spec. Unlike a deployment, a stateful set maintains a sticky identity for each of its pods. These pods are created from the same spec but are not interchangeable. Each has a persistent identifier that it maintains across any rescheduling. Stateful sets are a Kubernetes resource designed to manage stateful applications. Key features of stateful sets include stable and unique network identifiers. Each pod gets a unique name that follows a strict ordinal index, which remains with the pod despite rescheduling. Stable and persistent storage. Stateful sets use persistent volumes to provide stable storage beyond individual pods' lifecycle. Finally, ordered and automated rolling updates. Deployment and scaling operations respect the order of the pods, ensuring a predictable and safe rollout of changes. The architecture of stateful set involves several key components, including pods, persistent volume claims, and a headless service. Pods, as we know, are the basic execution unit within Kubernetes. In the context of stateful sets, each pod has a stable identity derived from the name of the stateful set and its ordinal index. Persistent volume claims used by pods in a stateful set to request and bind to persistent volumes, ensuring stable and persistent storage. One thing to note is that deleting or scaling a stateful set will not delete the volumes associated with the stateful set. This is done to ensure data safety, which is generally more valuable than an automatic purge of all related stateful set resources. Finally, there is the headless service. This is a particular type of Kubernetes service that controls the domain of the stateful set. It provides a consistent networking interface without load balancing or a single IP address. Deploying a stateful application using stateful set involves defining the stateful set resource, specifying the pod template, specifying the volume claim templates, and the headless service for network identity. You are responsible for creating this headless service. The stateful set controller then manages the lifecycle of the pods according to the defined specification. Stateful sets ensure that pods are deployed and terminated in a predictable order. For example, new pods are created in ascending order of their ordinal index when scaling up. Conversely, when scaling down, pods are terminated in descending order. Stateful sets support rolling updates, allowing sequential updates to pods within the set. This process respects the ordered deployment and scaling principles, ensuring minimal disruption. Management tasks such as scaling, updating, and handling pod failures are facilitated by the stateful set controller. Now let's talk about the benefits and advantages. Using stateful sets for managing stateful applications offers benefits, including predictability. Stable, unique identifiers and ordered operations predict the application's behavior. Second advantage is durability. Persistent storage ensures data survives pod restarts and failures. Finally, there is scalability. Stateful sets allow scaling stateful applications while maintaining specific requirements. Please note that stateful sets don't provide any guarantees on the termination of pods when a stateful set is deleted. To achieve ordered and graceful termination of the pods in the stateful set, it's possible to scale the stateful set down to 0 prior to deletion. The episode will continue after this short message. If you like our work and would like to support us, you can visit buymeacoffee.com/Chintu. That is buymeacoffee.com/CHINTU. Now, back to the episode. While stateful sets provide a robust solution for managing stateful applications, there are few challenges and considerations. Number one, complexity. Management of stateful applications is inherently more complex, requiring careful handling of storage and identity. Number two, storage management. Admins must ensure the underlying storage system is reliable, performant, and properly configured. And finally, number three, backup and recovery. To prevent data loss, implementing robust backup and recovery strategies is crucial for stateful applications. Before we end, let's discuss few of the best practices to effectively use stateful sets. Firstly, implement proper backup and disaster recovery strategies. And secondly, monitor and manage resources. Use Kubernetes tools like Prometheus and Grafana to monitor your stateful sets. That's it for this episode. Thank you very much for listening to us. You've been listening to Kubernetes Notes, and I am Fanishi Della. Thanks.
If you like this episode, please consider following us wherever you hear your podcasts.